Assignment 6.6. So this lesson was on finding volumes by rotating around an axis or rotating around a line. By rotating the cross section is going to be a circle. And so sometimes it's a solid circle, that's called a disk, or sometimes there's two involved and there's a hole in the middle. So it creates like a donut, and that's called a washer when there's a hole in the middle. So whatever situation we come up with, we'll do it together, and we'll see if we can set this up. Cross-section is a circle, so we're going to constantly use pi r squared. And when we set up the integration, pi is always going to be written in front of the integration when we do it. So from problems 1 through 4, use a disk or washer for finding the volumes of the solids described. Re-sketch each figure on your assignment sheet. Show at least one representation of that base and label the radii for each figure. So in number 1, you're given a graph, which is nice, of y equals the square root of 1 minus x squared. That's actually half a circle. Semicircle. And y equals 0. So I'm going to draw that graph, sketch it again here. And it says, take and revolve that base of a semicircle, revolve it around the x-axis. So there I drew it again. I'm going to draw what will represent the radius. So for a known cross-section, that was the diameter. But if I'm taking this and I am revolving this, I'm revolving this around the x-axis. This shape above would then be below. So if I'm rotating this, this does not describe the diameter because it goes above, below, and it's rotating a full rotation around it. So what's above goes below, above, below, and rotating. This is representing the radius. And the radius here is going to be top, subtract bottom. So the top is the square root of 1 minus x squared. The bottom of this is 0. So when you subtract 0, this represents the radius. So if I want to find the volume that's created by doing that rotation, it's going to be an integration question. The lower limit is -1. The upper limit is +1. And the formula is pi r squared. And it'll be dx because it's perpendicular to the x-axis. So there's pi r squared dx. Take what's the radius and plug it in. And there it is. Now, what did it ask you to do again? Let me just remind myself. So for problems 1 through 4, do the setup, but don't actually find the volume from 1 through 4. So there's the answer. This is the answer to part A. Now, the answer to part B, I'm going to redraw it. So for part B, it says revolve it about the line y equals -1. It even tells you what's going to happen. It's going to be a washer, not a disk. But let's redraw this with y equals -1. A little smaller diagram, which is fine. So there it is. But this time, you're going to take this and you're going to revolve it around the line -1. So there's the line y equals -1, and you're taking this and you're revolving it around that line. I'm such a bad drawer. But you're revolving it around that line. And what it means is when the line of revolution, if there is a space between the area that you're revolving and the line of revolution, and you can see the space there, it's going to create a situation where we need two circles. We have an outer circle, we have an inner circle, and then we subtract them. So that's a little more complicated when it's a washer. I want you to notice the one above, that when you revolved it around the x-axis, there is no space there. Like the whole area is touching the line of revolution. So if it's touching that revolution line, then it's a disk. If there's a space involved, it's going to involve two radii. So here we go. So for this one, it starts the same way, which is pi. We're still integrating from -1 to +1. But instead of having one radii, we have two. So I'm going to set it up so I understand that. So there's one radius, so that's one circle. And then subtract the second one, there's the other one. And so you can think of this as R1 and R2, but it's the big radius, subtract the small radius. So it's good to understand the template of how to find the volume. So pi, the big radius squared, subtract the small radius squared, and then what's left over is the volume. So first of all, how do I find the big radius? So start from the line of revolution, and then I want you to draw to the outer part of the area. So the line of revolution all the way through the area to the outer part. And I want you to understand that pink line right there represents the big radius. The line of revolution all the way through the area to the outer part. And then I'm going to go top, subtract bottom. Now the top is that semicircle, which is the square root of 1 minus x squared. That's the top. The bottom is -1. So we're going to subtract -1. Or in other words, we're going to add 1 to that radius, if you think of it. Subtract negative. And that's squared. So that's top, subtract bottom. For the second radius, that we start again at the line of revolution. But this time we stop at the beginning of the area. So we don't go through the area. We start from the line of revolution and then stop at the beginning of where it starts the area. So to the bottom of it. This one goes to the top. This one goes to the bottom. So again, I need to go top, subtract bottom. So I'm going to remind you that this is y equals 0. This x-axis. So it's really 0, subtract -1. Or logic, how long is that radius? If you look off your graph, the radius length is 1. But if we practice the template, it's 0, subtract -1. And that's it. This one is a disk, and this one's a washer. We're on to number 2, and we're not giving up. Number 2. In number 2, again, I'm thankful there's a graph. It's a cube root. So it's the cube root of x plus 2 and y equals 0 and x equals 2. So I'm going to redraw that graph here. I'm just redrawing it and I'm shading it in. And it says revolve it about the x-axis to begin with. So let's do that together. So I want you to draw the graph and x equals 2. This is y equals 0. So if you draw all of it, the fourth root, x equals 2, y equals 0. What's the area trapped with all three sides? That's it. We're going to take this area and we're going to revolve it around the x-axis. The first thing I notice is this area is touching the x-axis all the way through. So that makes it a disk. There's no space. So to start with, it's an integration problem. What's my lower limit? That's -2. And what's my upper limit? That's +2. Because it's revolving around the x-axis, everything's going to be x's. The cross-section is a circle, which is pi r squared dx. Pi r squared dx. So if I draw the radius, which is this is the radius, and I'm going to revolve it around, what algebraic expression represents that radius? Well, it's going to be the top subtract the bottom. So this curve is this on top, subtract the bottom, which is 0. So when I go top, subtract bottom, subtracting 0 doesn't change anything. So it's just the 4th root of x plus 2. Done. That's the volume revolving around the x-axis. The second one is revolving about the line y equals 2. So I'm going to redraw it, but this time I'm going to have y equals 2 as part of it. But, like, if I plugged in 0 for the y-intercept, the 4th root, like 2 is above this area. It doesn't even really matter how far above the area. Just know that it matters that there's a space. So again, what matters is that there's a space between this area and y equals 2. There's a space, so that tells me there are 2 radii involved. Okay. So, we're just going to slowly do it. This is an integration problem. Again, what are my bounds? My lower limit is -2. My upper limit is +2. Because there's a space, it involves 2 radii. Now, this is going to start with pi, because it's pi r squared, subtract, and really we can put parentheses around all of that, dx. So this represents the big radius, and this represents the small radius. All right, so how do I know what the big radius is? So start with your line of revolution, which is y equals 2. Start there, and draw a line straight down through the area. So start there all the way through the area. What represents that? Now, if you look really carefully, you could just see the answer is 2. But you could also go top, subtract bottom. Remember, the axis is 0. So 2 take away 0. The big radius there is 2. What represents the smaller radius is we start at the line of revolution and draw it to the front of the area. So we don't go through it. You go from the line of revolution all the way up to it, but not through. That's the second radius. So you're going to revolve around and revolve around, and when you subtract, that's the volume you're looking for. So what expression represents the second radius? Well, it's top, which is 2, subtract the bottom, and in this case, the bottom is the curve, and that is the 4th root of x plus 2. And there's the setup for a washer. So it's helpful to be able to draw a sketch of it and draw the radii right in the problem. Take your time, breathe, and be able to set it up and believe in yourself. I know this is an upper level calculus lesson, but I know you can do it. Number 3. In number 3, the region is bounded by the parabola y equals x squared. But we also have a slanted line, y equals 2x. And we're revolving it about the x-axis, and then we're going to revolve it about the line y equals 5. So the first one and the second one, both of these are going to be washers because there's a space between the area and the axes. And there'll be a space between this and y equals 5, which will be above. Okay, so step 1 is we're going to draw it. It's just a sketch. So x squared, you can draw that. And if you want, you can draw the other half. And then y equals 2x starts at the same spot, but it goes up 2 and over 1. And then that's the area of that. What's important to recognize here is that the line is above the parabola. That's by sketching it. To find my limits, I take the two equations and make them equal to each other. You're not given them, so you need to solve them. X squared equals 2x. Subtract 2x, make it equal to 0. Factor out an x. And then when you solve this, the lower limit is 0 and the upper limit is 2. All of these questions start with pi because they're circles. Because there's a space, so I'm revolving this around the x-axis, there's a space here between the area and the axes. I need to draw the radii in. So the first radii, the big one, starts at the line of rotation through the area to the top. So the big radius will be top, subtract bottom. Now our bottom is 0. That's the axis that we're revolving around. So it's 2x subtract 0, which is just 2x. And then I subtract, and then I want to understand my small radius. So if I draw the second one, it goes from the line of revolution up to the area, but not through it. So up to the bottom of it, that represents the second radius, the smaller one. And again, what represents the top part there is the parabola. This is x squared subtract 0, or just x squared. And again, I need to square it. And again, you could put parentheses around all of it to tie it together. So this represents the small radius squared. This represents the big radius, the first one represents the big radius squared. The second one represents the small radius squared. And that's the setup to find a volume. And again, it's going to be a washer, a hole in the middle, because of the gap between the area and the line you're revolving around. Now, the second one had to do with the line y equals 5. So it's important to know this point up here. Remember, positive 2? 2 squared. This point up here is 2, 4. Because if you went 2 times 2 or 2 squared. Now, why do I care? So when I do the line of revolution here, 5 is going to be above the area. So 5 is above it. Remember, this is 4. It's trapped, done. So 5 is above it. Now, can you understand how you would find this? See if I can change colors. I don't know if I have... Oh, I have a yellow. Let me do that. So for the second one, so I don't have to redraw it. Again, because there's a space between the area and the line you're revolving around, it's going to involve 2 circles. The bounds are the same. it goes from 0 to 2. The big radius, you start at the line of revolution and go through the area. So start at the line of revolution, go through the area to the bottom, and then you go top, subtract bottom, which is the bottom of the curve there. So the top is 5. That's y equals 5. So the top is 5, subtract, and the bottom there is x squared. There's your first radii. That's the big one. Subtract. Now the smaller one is you take from the line of revolution and you stop at the beginning of the area. This represents the big radius. This represents the smaller radius. So the smaller radius, again, is top, subtract bottom. So that's 5, subtract 2x. And it's going to come with practice. So can you figure out the big radius, the small radius? That's the template. It's pi. It's the big radius squared minus the small radius squared. And it just takes some patience and practice to be able to understand what expressions represent these things. So there's A and B. Number 4. In number 4, you have y equals 1 over x squared, x equals 0, y equals 1, and y equals 4. This time we're revolving it about the y-axis, so it's going to be sideways. All right, let's draw this. So there's the curve on the right side of y equals x squared. It's bounded by x equals 0. It's bounded by y equals 1. And y equals 4. So we have y equals 4, y equals 1, x equals 0, and the curve. So can you see the 4 sides to it? Shaded in. There it is. So notice we have 1, 2, 3, 4. They represent the 4 sides of the shaded area. One side's curved. And we're revolving it around the y-axis, so it's going to be sideways. Now, if you revolve it around the y-axis, look at the area, and notice the area is touching the y-axis through the whole thing. There's no space. So the first one, part A, is going to be a disk. But in order to do it with y, the bounds are going to be the lower y to the upper y. So our bounds go from 1 to 4. That's the lower y value to the upper y value. It's still going to be pi r. Now, like I said, this one's going to be one circle because the area is touching with no space the line that we're revolving around. So if I'm revolving this around sideways, I can't have y equals this. So I actually have to change that to x equals. So to do this, I'm first going to multiply both sides by x squared. I'm trying to get x by itself. So multiply by x squared, then divide by y, and then take the square root. Now I only want the positive square root. This is positive and negative. This is the positive. The negative would be on the left. I don't even need that. It stops at 0. So I don't need the negative, just the positive one. And it's the square root of 1 over y. Okay, so now I know what that curve is. This is x equals the square root of 1 over y. That's it. So I have to rewrite it so it says x equals, and it's in terms of y when I put it in here. What's the length of this radius? it's the right, subtract the left. So the right is the curve, subtract 0. So when you subtract 0, it's just the square root of 1 over y. So that's the radius. You square the radius, dy. And that's the setup to find the volume. For part B, you're revolving around x equals -1. So I'm going to do this one in yellow. X equals -1 is here to the left. And so now do you see there's a space between the area I'm revolving and the line of revolution? Because there's a space, there's going to be 2 radii. So the beginning part is pi. We are integrating again from 1 to 4. But then we're going to have a big radius and a small radius. So the big radius starts with the line of revolution, and it goes all the way through the area to the end of the area. And then you go right, subtract left. So on the right is the curve, which is the square root of 1 over y. Subtract the left, which is -1. And then you square it. And now how about the small radius? The line of revolution up to, I'll do it here. So the line of revolution up to the area. So it's not curved at all. That distance of that yellow line is just 1. Or you can go right, subtract left, which is 0, subtract -1. Or just recognize it's 1. That's the distance. And that's dy. And there's the setup to find the volume when you revolve it around sideways. And you don't have to simplify it. And if you had to, you could type that in your calculator. All right. For problems 5 through 7, again, we're going to set it up. But we're not going to find the volume exactly. We're just going to know how to set it up. Can we sketch the graphs? And can we? Because that's where the whole problem is. Do you have the ability to sketch it, find the limits, and to set it up? And it only is going to be better when we practice. All right, so number 5, we have y equals 1 over x. We have y equals 0. We have x equals 1, and x equals 4. So I'm going to graph all 4 of them. And we're first going to revolve it about the x-axis. And then I'm going to revolve it around y equals -3. And then I'm going to revolve it around y equals 5. So step 1 is I'm going to sketch this. I'm going to do it underneath. So to sketch this, I'm actually going to start with y equals 0. So y equals 0 is along the x-axis. X equals 1. That's a vertical line right there. And x equals 4. So we have x equals 1, x equals 4, y equals 0, and now we have the curve that's going to come through. So the curve 1 over x looks like this. If I say, hey, what does 1 over x, what does that look like? It's a reciprocal function where it kind of looks like this, right? That's what it looks like. So we just need this part up here, not the negative part over here. So there's that picture there. Can you shade in the area that you're going to revolve? I know it's not easy. It's practice. Do you know your algebra so you can sketch it? And then shade in the area that you're going to revolve. So first we're going to revolve around the x-axis. And so I notice the area is touching the x-axis. So it's just a disk, not a washer. So one circle. My bounds, I already know. They go from 1 to 4. So when I integrate, I'm going to integrate from 1 to 4. I know it's pi. I know the radius is represented as top subtract bottom. So that's 1 over x subtract 0, or just 1 over x. I square it dx, and it's over. Now, what happens if I revolve it around a different line? It creates a space, which means we're going to need 2 circles instead of 1 circle. So if it's y equals negative 3, that's down here. And again, I'm going to use color to help me out here. So if I revolve around here, the big radius is this one right here that goes through the area. So when I write this, it's going to be pi. Again, I'm integrating from 1 to 4. That hasn't changed. And then the big radius is top subtract bottom. So that's 1 over x subtract negative 3. So top is 1 over x. The bottom is negative 3. Top subtract bottom. That's the radius. So that's pi r squared. Subtract. Now, how about the smaller radius? Well, it's not even a curve. So for this one, top subtract bottom, what's the length of that? And that length is just positive 3. And there's the setup. All right, one more, and it's the setup for 5. Now, this doesn't need to be to scale. It just gives you a visual to know how to know top subtract bottom. So I'm going to take y equals 5 here. It's above. I'm just creating a visual. I'm going to change colors. Again, there's a space between the area and the line you're revolving around. So the first one, the big radius, goes through the area to the bottom of it. And again, you're going to go top subtract bottom. Now, since it goes to the bottom, when you go top subtract bottom, that number is just 5. So this is going to start with pi. We're integrating from 1 to 4. And the first radius is just 5. Top subtract bottom. There it is. Subtract. Now the second one, again, start from the line that you're revolving around. If you draw the second radius, it goes to the beginning of the area. So top subtract bottom. This bottom now is the curve, 1 over x. So that's 5 subtract 1 over x. And there's the setup. All right, if you need a break, you should take a break. I'm going to keep going. You can always come back to it. Number 6. In number 6, you have y equals the square root of x equals 0, and y equals 2. And then we're going to revolve it about the y-axis. So now we're going the other direction. So it doesn't even have to say perpendicular or anything. If you're revolving it around the y-axis, that means it's sideways. X equals negative 2. It's going to be sideways. And x equals 4 is going to be sideways. All right, so here we go. So we're going to draw it first of all. So underneath, let's draw it, and then we'll set it up. So first one I'm going to draw is y equals root x. That's what this looks like. That's the square root of x, and that's what the curve looks like. Then I have x equals 0, which is this, and I have y equals 2. Now, what's it? The curve, y equals 2 and x equals 0, I need you to shade in. It's that part right there that's shaded in. Now, to that area, we're going to revolve it about the y-axis, which is right here. So I'm going to revolve it around. What am I looking for? is this area touching the y-axis through the whole area? Yes, there's no space. So it's a disk, one circle, and we're going to rotate it. Now, if I'm going to go sideways, I can't have it say y equals root x. Instead, I have to solve for x. So instead, I'm going to write it as square both sides. So x is equal to y squared. That's what I need to. So this is really x equals y squared. So it's in terms of y. So when I go sideways, that's what I'm going to use. So now what's my radius here? It's going to be right subtract left. So right subtract left would just be y squared take away 0, which is y squared. And what are my bounds? So I need an upper bound and a lower bound. Well, the lower bound is 0, and the upper bound is 2. So here's your lower limit and your upper limit, 0 to 2. One circle, pi r squared, and we just said the radius is y squared take away 0, or just y squared. Make sure it says dy at the end, and that's it. All right, next one is x equals negative 2. So again, it doesn't need to be to scale, but what you need to recognize is that there's a space now between the area and what you're revolving around. It's going to involve two circles. So when I come here, it's going to be pi. It's still going from 0 to 2, but now we're going to have two radii. So one radius is the big one. So from the line of revolution all the way through, and you're going to go right subtract left. So if I go all the way through, the curve is on the right, and this line is on the left. So you're going to go y squared subtract negative 2. And then we need a smaller radius. Now the smaller radius goes to the front of it. Doesn't go through the area. And I want you to recognize that this is no curve a part of it. It just goes from negative 2 to 0. So the length of that is 2. And you've set it up. All right, last one here, part C. Draw the line x equals 4. So again, it doesn't need to be to scale. But what you do need to recognize is when you draw the line x equals 4 that there's a space between the area you're revolving and the line x equals 4. Because there's a space, there's going to be two circles. So it's pi. It goes from 0 to 2. Those things haven't changed. But now what represents the big radius? So draw it in. So the big radius goes from the line you're revolving through the area to the left side of the area. Now, that's just a flat line. There's no curve involved. So what's the distance from that? And that distance is 4. So the big radius is 4. The smaller radius goes from right, subtract left. That is the curve, is the smaller radius. So there we're going to go 4, subtract the curve. So it's 4 subtract y squared. And there it is. The more you practice, and again, if you're getting worn out, take a break, come back. And then when you feel fresh, then continue to come back to this. Number 7. I'm going to go to number 8, and then I'll do a second video. So the region bounded by y equals x squared subtract 2 and y equals negative 1. And then revolve it about the x-axis and revolve it about y equals 1. All right, so step 1 is to sketch it. Are you able to sketch these two things? The parabola and y equals negative 1. I bet you can. I'm going to do it here on the right. So where's the vertex for this and it's at 0, -2, just curve it up. It's just a sketch. So it's 0, -2, curve up. Then y equals -1. And then what's the area between that curve and y equals 1? Shaded in, the area that's trapped. Bounded. There it is. So that's the area that you're revolving around. We're first going to revolve around the x-axis. Another name for the x-axis is y equals 0. All right. Is there a space between the area and the x-axis? Yes. So that means that there's going to be two circles. I need to know my limits. I need to know the lower limit and the upper limit. It's not given. So to find the limits, we're going to take the two equations and make them equal to each other. Then I'm going to solve for x. So I'm going to add 2, take the square root, and know the answer is positive and negative. So my lower limit is -1 and my upper limit is +1. So it's pi, and I'm integrating from -1 to +1. So I'm going to have 2 radii. So my big radius, start with the line you're revolving around and go through the area, and then recognize what that is. Oh, I should do that in pink here. And then go top, subtract bottom. So the big radius will be 0, subtract the curve. Now be careful. Use parentheses so you don't make a mistake with the sign. So top, subtract, bottom. Make sure you use parentheses when you subtract like that, so the negative sign will be distributed, and square it. Subtract. Now the small radius will be easier. This is the small radius. Top, subtract, bottom. That's just a straight line there. That distance there is 1. dx. Done. Is this getting any easier? I hope so. Let's try it again. Let's do it with y equals 1. So I'm going to draw y equals 1 here. It doesn't need to be to scale. So there's y equals 1. The limits are the same. It's pi, and it goes from -1 to +1. And again, we have 2 radii. The first one, the big radii, goes from +1 all the way through the area. So it's going to be 1 subtract, and it's x squared subtract 2. So top, subtract bottom. And then the smaller radius goes from the line of revolution to the beginning of the area. There's no curve involved there. That's just 1 subtract -1, or that whole distance is 2. Done. So if I did it in yellow, that's the small one, and then the bigger one goes all the way down to the bottom. I know it's hard to tell there. So you have the small radius and the big radius, and we're constantly going top, subtract bottom to find that. Number 8. This will be the last one for this video, and then I'll do another video to do the next part. Without using a calculator, find the volume. So we're not just going to set it up, we're going to find the volume of the solid form when the region is bounded by y equals the cube root of x equals 0, and y equals 2. So we're going to go around the x-axis, and we're going to do it around the y-axis. So step 1 is we're going to draw a picture of this. So do you know what x cubed looks like? And the answer is, it kind of looks like an S. That's the picture of x cubed, or cube root of x. Then x equals 0, that's here, that's the y-axis. And y equals 2, That's y equals 2. So what's the area trapped by all three? There it is. And then fill it in. So you have the cube function, cube root function, x equals 0, y equals 2, and then fill in the area that's trapped by all three sides. I want to take this area and revolve it around the x-axis. Is there a space between this area and the x-axis? Yes. So we're going to have two circles. So it's going to be pi. Do I already know the bounds for the x? And so one bound is 0. Do I know this bound up here? I don't. So I need to make it equal to 2. So I'm going to take these two and make them equal to each other. So that's the cube root of x equaling 2. To undo this, I have to cube both sides. So if I cube both sides, 2 cubed is 8. So this bound up here, I didn't know what it went from 0 to what. It's not to scale. But that right there is 8 by making the two y equal parts, making them equal to each other and solving it. So this is going to go from 0 to 8. The first radii, I'll do it in pink, goes up and down. So from the x-axis all the way through the area, that distance is 2. Subtract. The second one goes to the bottom of the area, which is the curve. So the curve is on top. So it's the cube root of x. Subtract 0, or just the cube root of x. And there's your setup to find the volume of that. Top, subtract bottom, 2 circles. Now, I actually have to find the volume of it. So we're not done. Haha. So to find this, I'm going to simplify it just a little bit. That's 4. I'm going to change this to a fraction, exponent. So the cube root squared would actually be 2/3. So that's what it would look like. Now I'm going to do the antiderivative. Pi can just stay in front. So the antiderivative of 4 is 4x. The antiderivative of 2/3, you add 1 to the exponent, so that's 5/3, and then times the reciprocal, and then I'm integrating from 0 to 8. The last step is you plug in the upper bound and then the lower bound, and I don't need to simplify it. So I'm going to plug in 8. Now, after I plug in 8, when you plug in 0, just double check. 0 does give you the answer 0. So I don't even need that part. So I could simplify it if I wanted to, but that's the exact volume of what I just revolved around. All right, you ready for part B? Let's look at part B. This will end the video here, part B. So this one's the y-axis. And because I'm revolving around sideways around the y-axis, the first thing I notice around the y-axis is that the area is touching the y-axis all the way through. So because it's hugging the axis that I'm revolving around, it's one circle. So that's good news. The second part is I have to change the bounds. So now what's the lower bound compared to the upper bound? So that's 0 to 2. I don't have to even solve that. So it's pi 0 to 2. But this now needs to be in terms of y. So do you have the skill to take the cube root of x? Can you solve for x there? So the same equation, you could cube both sides. And if you cube both sides, x is equal to y cubed. So this curve can also be called y cubed. And then I'm going to go right, subtract left. So that's y cubed, subtract 0. Or just y cubed. And if you revolve it around there, that's what you get. Now, we actually need to find the volume. So that's y cubed squared. That's pi r squared. Now, how would I find the volume here? So 3 times 2 is y to the 6th. Now, do the antiderivative. Just keep pi in front. You add 1 to the exponent and divide. we're integrating from 0 to 2, and then you plug in 2, and then you plug in 0. So it's 2 to the exponent 7 divided by 7. When I plug in 0, the answer is 0. And there's the exact answer for the volume. And you don't have to simplify it. All right, Mr. G Math, I am so proud of you. This is a difficult assignment. It is not impossible, but it does take work. And I'm really proud of you for doing your work. Mr. G Math, over and out. Until next time, in the next video.